Welcome to Data Engineering with Subhadeep. Today, we are diving deep into a critical topic: ETL versus ELT in practice. We will move beyond the theoretical concepts to explore real-world applications, a case study, and performance benchmarks. Here is our agenda for today. We will start with a quick refresher on ETL versus ELT, then discuss practical scenarios to decide when to use which. The core of our session will be a detailed case study on migrating from on-premise ETL using Informatica to a cloud-based ELT with Snowflake and dbt. Finally, we will cover the pros, cons, performance benchmarks, and key takeaways. Let's start with a quick refresher on ETL. ETL stands for Extract, Transform, Load. Data is first extracted from source systems. Then, it undergoes transformation on a separate, dedicated ETL server, where cleaning, joining, and aggregation occur. Finally, the transformed and refined data is loaded into the target data warehouse. The key here is that transformations happen before the data ever reaches its final destination. Now, let's look at ELT. Extract, load, transform. Here, data is extracted from the source systems and immediately loaded, often in its raw form, into a highly scalable data lake or staging area. The transformations, such as cleaning, joining, and aggregation, then occur directly within the powerful cloud data warehouse itself, leveraging its compute capabilities. The key distinction is that raw data is loaded first. Now, the crucial question: when to use ETL versus ELT? Choose ETL if you are dealing with legacy on-premise systems, have strict data privacy requirements before data lands, or if your data volume is manageable. It is also suitable if you have a budget for dedicated ETL tools and need complex transformations up front. On the other hand, choose ELT if you are leveraging cloud data warehouses, want to store raw data in a data lake, handle high volume and varied data, prefer pay-as-you-go cloud compute, or want to empower your data analysts. Now for our practical case study: migrating from on-premise ETL to a cloud ELT architecture. Our goal is to modernize the data architecture, improve scalability, and reduce operational costs. We are transitioning from Informatica PowerCenter, a traditional on-premise ETL tool, to a modern cloud-native ELT stack leveraging Snowflake for the data warehouse and dbt for transformations. Imagine a large enterprise with years of data processing built on Informatica. In our current state, data flows from various operational databases like SQL Server and Oracle. Informatica PowerCenter, running on dedicated on-premise servers, performs all the complex transformations through custom mappings and batch processing. Finally, the transformed data is loaded into an on-premise data warehouse, such as Teradata. This setup often faces high maintenance, rigidity, scaling challenges, and costly licenses. In the new ELT architecture, data from operational databases and various SaaS sources is ingested directly into Snowflake's raw layer using tools like Fivetran, Stitch, or custom Python scripts. Once loaded, dbt, the data build tool, handles all the transformations within Snowflake using SQL. This creates curated and consumption-ready layers, leveraging Snowflake's scalable compute and storage for efficient processing and analysis. Let's explore the advantages of cloud ELT with Snowflake and dbt. Firstly, immense scalability and performance, leveraging the cloud's elasticity for massive data volumes. It is highly cost-effective with a pay-as-you-go model, eliminating upfront hardware costs. You gain flexibility and agility, allowing faster iteration and adaptation to changing requirements. It enables storing all raw data for future analysis and compliance, which is a huge benefit. With dbt, transformations are SQL-based, Git-versioned, testable, and modular. Finally, it democratizes data, empowering analysts to build and manage data models directly. However, cloud ELT also comes with its challenges. Initial load complexity can be significant when migrating historical data. Ensuring security and governance for raw data in the cloud is paramount. Cost management requires careful monitoring to avoid unexpected expenses. Without proper data governance, raw data in a data lake can quickly turn into a data swamp. There is also a potential skill set gap, requiring teams to learn new tools like dbt and cloud platforms. Finally, the migration effort itself demands significant re-engineering of existing ETL logic. Now, for some performance benchmarks based on a typical enterprise data warehouse workload processing over 1 terabyte of data daily, Informatica ETL typically takes 4 to 6 hours for batch runtime, with annual infrastructure costs ranging from $500,000 to over $1 million. Developer productivity is lower due to its GUI-based nature and less Git-friendliness, and scaling requires manual, costly upgrades. In contrast, Snowflake and ELT reduces batch runtime to 1 to 2 hours, with annual infrastructure costs typically between $100,000 and $300,000. Developer productivity is higher thanks to its SQL-first and Git-native approach, and scaling is automatic and on-demand. Remember, actual numbers will vary based on workload and configuration. Here are our key takeaways and best practices. Choose between ETL and ELT based on your specific use case. ETL suits legacy systems or strict preload governance, while ELT excels with cloud-native architectures, offering agility and scalability. The cloud is a true game-changer, where ELT thrives within powerful cloud data warehouses. dbt is a crucial tool for ELT transformations, promoting modularity, testing, and collaboration. Remember, data governance is paramount, especially when loading raw data first. Invest in skill set evolution for your team, focusing on SQL, cloud platforms, and data modeling. Finally, start small, iterate, migrate critical pipelines first, learn, and then scale up. Thank you for watching this deep dive into ETL versus ELT in practice. I hope it was insightful and provided valuable real-world perspectives. If you enjoyed this content, please like, comment, share, and subscribe to Data Engineering with Subhadeep for more data engineering tutorials. Your support helps this channel grow.